if the electric potential is KQ over R for a charge, then if we wanted to find the small contribution of electric potential due to a small contribution of charge, then we can do that. If we integrate both sides, then we find that if we integrate this between 0 and V, we'll get the integral of K dq over R. Remember that dq business? Lambda and sigma and fun stuff like that? Okay, but notice there's no R hat right here. So there's no direction, okay? This is a scalar. That's right, a scalar. All right, no R hat. Okay, so y'all like a box. Let's throw a box around that. That's what we're about to use. So let's start with something easy, like a ring of charge. So let's, we've done electric field due to a ring of charge. So let's find the electric potential at a distance x from a ring of charge. And I'll draw it so you figure out what x means. It's always a lot easier. With a radius of a. Okay, so let's see. So you're looking at the side view of a ring. Pretend like I'm a great artist there. So there's the side view of your ring. And here is the center of the ring, and dot, 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 dot. Out here is our spot that's a distance x away. And the radius of this ring is a. What do you think so far? I'm not recording. All right, so electric potential is a scalar. So we need to figure out what electric potential is contributed at this point. So dot, 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 dot. That point right there due to this little dq. And that little dq is the same as a little dq over here. And the electric potential, if I could draw cool dots that kind of go into the page right there, all right, would create an identical electric potential at that point. And oh my goodness, this one right here, this little dq bit would also create an electric potential identical to the first one, because aren't they all the same distance away? When you think about that cone-ish type picture there. Okay, so then we need to find R, because that's the distance. And it looks like R would be what? Yeah, the square root of a squared plus x squared. So let's see. Our electric potential would be the integral of k dq over R. We'll make a substitution for R. And that would be the square root of a squared plus x squared. Now the cool thing about dq in this type of problem is that it's exactly the same no matter where you are. So we don't need to substitute in for a dq value at this point. We can just sum it up from no charge to all the charge. Okay, this does not change. I'll write it out here. Not varying. Okay, so we don't need to substitute in for that dq. So then this is a pretty easy cheesy lemon squeezy integration, right? KQ over the square root of a squared plus x squared. What do you think about that? Questions?